This lesson is going to focus on solving trigonometric equations. What you're going to be presented with is something like this. Determine all solutions, and then you'll be given a problem, like say this one. Now what we mean by determine all solutions, what I'm really telling you is that there are infinitely many answers. Let's solve this way we would solve an ordinary equation, in that you would want to try to isolate the variable. Isolating the variable is a little iffy because you'll notice that we have the sign of the variable. So the next best thing is to isolate the sign of x instead of just x. Let's go ahead and subtract 3 sin x from both sides. That leaves us with 1 equals negative 2 sin x. If you divide out the negative 2, we get negative 1/2. Now let's go ahead and draw a picture for that. Recall where the sign is negative. The sign is negative in quadrant 3 and in quadrant 4. So our answers are simply going to be in those particular quadrants. Let's go ahead and draw the angle out. And you'll notice that with respect to the reference angle right here, the opposite side is negative 1 and the hypotenuse is 2. So we're following this here. And you might notice that this is one of your special triangles. Remember, with special triangles you have a 1 and a 2. If you use the Pythagorean theorem, you'll find that the other side is the square root of 3. That makes our reference angle 30 degrees. So here's the question. The reference angle is 30 degrees. Therefore, what is the actual angle? In other words, from here all the way to here, how many degrees is that angle? Hopefully you recognize that the angle is 210. The reason being is because when you get to here, that's 180, and then keep in mind past 180 we went another 30 degrees, so 180 plus 30 is 210. Now that would be one answer, but we have to kind of keep in mind that there is more than one. We have to account for all the coterminal angles, because we can stop here and get an angle, but what if you kept on going? And if you kept on going, we'd wind up back here again. That would be another answer as well, and we'd have to account for that one. Or if we kept going and then back to here again. So all the coterminal angles, we want to get those in as well. So this is how we do it. What we do is we tack on 360 degrees and then a multiplier n. So what we say is this: it's 210 degrees. And then this part here accounts for all the coterminal angles. However many times you spin around 360 degrees, and we say that n is an integer, meaning we go around in the positive direction 1, 2, 3, 4, 5 times, or in the negative direction, negative 1, negative 2, negative 3, etc. In any case, that gets all of our coterminal angles for 210. Now, since we're supposed to get possible answers in quadrant 4, let's draw the triangle there too. We already know the reference angle is 30. So again, the question is, what is the real angle since the reference angle is 30 degrees? From here to here, hopefully you recognize that that's 330. And then we tack on the 360 degrees times n for the infinite number of coterminal angles. So that's your answers. 210 plus 360n, 330 plus 360n. Okay, what I want to do now is I want to give you a graphical representation of what we just did. Let's backtrack here a bit. Let's assume that it was written this way, where one side is equal to 0. So we get 0 is equal to 2 sin x plus 1. And this is a positive 2 sin x if you were to take this and move it over to the left-hand side. That's what we would have. This is the graph for y equals 2 sin x plus 1. I'm doing this, by the way, in degrees. Normally when you graph sine waves you do in radians, but since we were doing our answers in degrees, we'll stick to that. Y equals versus 0. This is telling you that we're looking for x-intercepts. So what you're looking for essentially is, the coordinates of this point here, and then the coordinates of this one, and etc. What is the coordinates of this particular point? Well, it crosses, remember what our answer was? 210, right? So that would take care of this very first intercept. And oh, by the way, you'll notice that it keeps crossing over. But that's not what I'm going to focus on. I'm going to focus on the coterminal angle aspect. Originally over here, we had to account for when this thing circles around again 360 degrees. Well, remember that the period is 360 degrees. So that completes one period. When you go to the next period, you'll see that we have a point here. So from here to here is another 360. Then another 360. So that's where that comes from. Likewise for 330, our other answer. After 330, you'll notice how this thing kind of slopes up, so that was our second answer. This would be another one. This here would be another one. And to get these values, you just add another 360, then add another 360. 360 is synonymous with the period of this graph. So that's the reason why we have that. If we had some other number in front of the angle, that would alter the period. And remember, the way we get that is by taking this value and dividing it into 360 degrees, or 2 pi if you're in radians. So that's the graphical representation of this. Okay, let's try another. Root 2 times the cosine of x minus 1. Again, what you want to do is you want to isolate this part here. So what we're going to do is we're going to move this negative 1 transposed to the other side. And that's what we get. And then divide by root 2. And that's what we get for our answer. Only we're not done yet. Let's go ahead and draw the picture for this, keeping in mind in what quadrants the cosine is positive in. Well, the cosine is positive here in quadrant 1. It's also positive here in quadrant 4. Starting in quadrant 1, this is the adjacent side. This is the hypotenuse that represents this ratio. And if you use the Pythagorean theorem, hopefully you figure out the third side. And I'll remind you again that these are your special triangles. Okay, so the reference angle is 45 degrees. Therefore, what's the real angle? Well, this one isn't so difficult because from here to here it's still 45 degrees. So it's just 45 plus 360n. What about the fourth quadrant? Well, we already know the reference angle is 45, so we don't have to do any major figuring out. The question is, what's the real angle going from here to here? And you'll notice we tend to do this in the positive direction. That's 315. So those are your answers. Here's another. Tan of x minus root 3 is equal to 0. Not much doing here. We want to isolate the tangent, so let's go ahead and do that. So the tan of x is equal to the square root of 3. And I want to underscore that's the square root of 3 over 1. So you should be picturing this as opposite. Oh, let's try again. Opposite over adjacent. Keep in mind the tangent is positive, so what quadrants is the tangent positive in? Most definitely in quadrant 1, also in quadrant 3. So there we are. So again, we have this thing of the reference angles are 60 degrees. Therefore, what are the real angles? Well, this one again is not much of a stretch. It's just 60 degrees. So that's 60 plus 360n. 360n, remember, refers to all the coterminal angles that we get for going around and around and around. The other angle, spinning from here to here, is 240. And there we have it. However, with the tangent, and this really only goes for the tangent and the cotangent, we can rewrite this in a different way. You'll notice that from this angle to the second angle is 180 degrees. And then to get back to here, that's another 180. Then another 180. Then another 180. And so on and so on. Because of that, you can just simply say that the answer is 60 degrees, and then we go plus 180n. And that gets all of our angles. Now, is this more correct than these first two? No, you're still stating what all the answers are. However, you'll want to keep this in mind because this is also an acceptable answer. If you were to do, say, a multiple choice test, you might see this answer represented instead of these two. That's it for this one. I'll see you next time.